Okay, now we're ready for section 2.1, which is the first part of this is degrees and radians, and the second part of this is going to be about arc length and area of sectors. So radians is just another way to call out the amount of an angle. So the first way we talked about was degrees. A circle is divided up into 360 degrees, and that's just what people decided to divide it up into. You could divide it up into as many different degrees as you wanted to, but that's what they decided to do. So there's 360 degrees in a circle, and so you can also split this up into something called radians. It's a different way to call out angles. So this is how a radian is defined. If you've got a circle, so here's my XY axis, and here's a circle centered on the XY axis. So pretend like that's centered. If you have a circle and we draw an angle here, so let's draw our angle in standard position. So the standard position of an angle is with the initial side on the positive x-axis right here. Okay. And the terminal side is counterclockwise, so that's standard position. So if we say the radius of this circle from the center to an edge is r, okay, and the angle that we're about to draw intercepts an arc length here, that this amount of the circumference is also r, then this angle right here, theta, is equal to 1 radian. That is how a radian is defined. When the radius is equal to the arc length, that is 1 radius. And so it turns out to make a full circumference of a circle, to get all the way around the circle, that from halfway around the circle, from here to here, is pi radians. And pi is a number. It's 3.14, and it goes on forever. But this is about, so this is about 3.14 radians. It takes about a little over 3 radiuses to get to here. And then from here to here, all the way around the circle is 2 pi radians. From here all the way around to here. It's 2 pi radians. So that's about 6.28. 6.28 radians. So if we talk about a circle, one complete rotation of a circle is 360 degrees or 2 pi radians. So we can convert between radians and degrees very easily with this little conversion, and we have that on our sheet there. It says to convert from degrees to radians, you multiply by pi over 180, or to convert from degrees, from radians to degrees, you multiply by 180 over pi. And how I keep this in my head is whatever it is I'm trying to turn it into is what's going to go in the numerator. So if I'm in radians and I want to turn into degrees, I multiply by 180 degrees over pi, or if I'm in degrees and I want to go to radians, I multiply by pi over degrees. So here I have this chart, and on your sheet, you don't have these numbers, but this is what I'd like you to put in. We're about to convert, so we're just going to do these conversions right here. If 30 degrees, we're going to convert that to radians. An exact form is when you have a pi, the symbol pi written in there. And then to the nearest tenth is when you put that in your calculator and you round to the nearest tenth. So both of these are radians. These are different ways to call this out. So let's just begin. This is how you're going to go about and do each one of these. I will fill in the answers. If you want to just try on your own, you can, but I'll go through each one of these. If we want to take 30 degrees, and we're going to convert it to radians, then we multiply by pi divided by 180. Now, if you want to write the 30 over 1, it's basically a fraction times a fraction, you can, right here, the degree symbols are going to cancel, okay? I can divide 10 into each of these, so that takes off the 0. And then you can say 3 goes into 18 6 times. So 1 times pi is pi, and 1 times 6 is 6, and it turns out that 30 degrees is equal to pi over 6, and that's the exact form. So I'm going to do, this is how I like to convert. I'm going to convert each one of these, 45 degrees times pi over 180 degrees, and if you want to write that like that. Turns out that 45 goes into 180 4 times, and so this is going to be pi over 4. 60 degrees, you will find, I'm not going to go through the conversion, you can do it the same exact thing. 60 degrees will convert into pi over 3. 90 degrees will turn into pi over 2. All right, if we're going to go backwards and we have 2 pi over 3 and we need to convert this into degrees, then it goes like this. We'll take 2 pi over 3. If we need to convert this to degrees, let's do this. 2 pi over 3. To convert to degrees, you multiply by 180 degrees divided by pi. So this time we see what's going to cancel. The pi's will cancel. I can say 3 will go into 18 6 times. So 3 will go into 180 60 times. And so then I just have, these are ones right here. 2 times 1 times 60 is 120 degrees over 1, or just 120 degrees. 2 pi over 3 converts to 120 degrees. Let's take pi and let's multiply by 180 degrees over pi. And what we see what happens here is these cancel. And we get 180 degrees is what this converts into. 5 pi over 4 goes like this. 5 pi over 4 times 180 degrees over pi. These will cancel. 4 will go into 180 degrees 45 times, and 5 times 45 is 135 degrees. Let me see. I think that's not right. Let me double check with my calculator to make sure. 5 times 45, 45 times 5 is 225 degrees, 225 degrees. I thought that was not right. 225 degrees. When you convert 270 to radians, you get 3 pi over 2. When you convert 11 pi over 6 to degrees, you get, just 1 second, 330 degrees is what you're going to get right there. Now, this is the other category of radians. So some people think that you always have to have a pi involved for it to be in radians, and that's not true. Radians is just a number. So if we want it not in exact form, but the nearest tenth, in some angles you cannot put in exact form because you can't put them in terms of a fraction like this. So radians, if we want this in to the nearest tenth, then we would just take pi divided by 6. So if we do that, if you take your calculator and you take pi and you divide it by 6, you're going to get 0.5235 and some other numbers. So if I say to the nearest tenth, then this is going to be 0.5. And so this means approximately equal to. You could go through here and say pi over 4. Let's do that. Let's say pi over 4 gives us 0.78. So that's going to be about 0.8 radians. Pi divided by 3 will give us 1.047, or about 1.0. Pi divided by 2, 1.57, or 1.6. 2 times pi divided by 3 will give us 2.09, or about 2.1. This is going to be 3.14, 3.1. 5 pi divided by 4 gives me 3.92. 3.9, about, this is approximately equal to 3 pi divided by 2, 4.7. And 11.11 pi divided by 6 gives me 5.75 or about 5.8 radians. Now, here's just a couple of things I want to point out. When you have radians, they will be indicated that the angle is in radians, not degree, either by writing out the initials RAD or the word radians, or by nothing. So this I know is in radians. If they say to me, here's an angle, that's in radians. And I know that because it doesn't have a little degree symbol. That's when the lack of the degree symbol means it's in radians. If they say theta is equal to 1.2 degrees, this is in degrees. Degrees will always be indicated by the little degree symbol. If this means radians, also this means radians. This is equivalent. So that's one thing I wanted to just point out. The other thing is fractions. Let's talk about fractions. I wrote these in different ways. I want to make sure that you see this is just fraction talk. If you have the fraction pi divided by 2, okay, pi divided by 2, you can write it like that. Oh, that's not a good one. That's not a good example. Or this could also, sometimes they call this 1/2 times pi. This is a way you could write this. These mean the same thing. What if I've got this one? Let's take 11 pi over 6. 11 pi over 6, I wrote it like this, 11 pi over 6. That means 11 times pi over 6. You can also write this as 11 pi over 6. You can also write this as 11 over 6 pi. These are all equivalent. So I want you to get used to seeing those different ways so that you know what goes in the numerator and what goes in the denominator. And so that's just what radians are. Now, we're gonna draw some circles, some angles, and we're gonna draw them in degrees, and we're gonna draw them in radians. But before we leave this chart, I want to draw a circle, and I want to draw out some angles that you guys will become more and more familiar with. And pretty soon we're gonna look at the unit circle. And so when we look at the unit circle, these angles will become very, very familiar to you. So let me draw myself a circle. And so we're going to go around this circle and we're going to name out some special angles. And the first time we do it, we're going to do it in degrees. And then we're going to come and we're going to do the same thing. And we're going to name these in, we're going to do the same thing. We're going to name these in radians. Okay, let me do a better job. I should really draw my circle first and then my axis. So let me do this. That one looks a little better. So let me see. Let's see, here's my circle, and let me just try to center it that way. That looks a little better. Okay, so now, this is our XY axis. I'm going to go around the circle, and I'm going to name some degrees. And then I'm going to name it in radians, and these are both equivalent. They're the same thing. Just one way we're talking about is in degrees, and one way we're talking about is in radians. And I'm doing this right now just to get you used to seeing the special angles we're going to be talking about. So, let's go around this circle. Let's see if my purple marker works. Let's do degrees in purple. Okay, good. So this right here is 0 degrees. Okay. So then if this is my initial side and then I go about this far, this would be 30 degrees. And then if I go halfway, I didn't mean to start with 30. I'll come back to 30. Sorry. Let's do this again. Okay. This is 0 degrees right here. And then we know a right angle, the x-axis and the y-axis meets at a right angle. We know a right angle is 90 degrees. So that means from here to here is 90 degrees. This angle right here would be 90. And then from 0 all the way to here, this angle right here would be 180 degrees. That is called a straight angle. So if we went from here to here, it's 90. From here to here is 180. From 0 all the way around to this bottom axis right here is 270 degrees. And then we know if we went from 0 all the way around to the same place we started, that would also be 360 degrees. So what we've just seen here is a coterminal angle. A coterminal angle is one that has the same initial and terminal side. So this is 0 degrees, but if we go all the way around, it's also 360 degrees. Okay, now let's talk about some other angles we can find. Halfway in between 0 and 90 degrees, if you take 90 divided by 2, you'll get 45 degrees. So right here, from here to here, is 45 degrees. That's one of the angles that you'll be seeing. Let's stop right here and let's compare that to radians. What would that look like in radians? Okay, right here, this is right here at the x-axis. We haven't gone anywhere. This is 0 radians, just like 0 degrees. Those are the same. Okay, but then 90 degrees, this 90 degrees right here, if I go from here to here, this is pi divided by 2. That's the same thing as 90, pi over 2. And then from here all the way to 180, here to here, here to here, this is going to be pi. And if I went from 0 all the way around the circle, the same as 360, this is 2 pi. But each one of these fourths is pi over 2. So from here to here is pi over 2, plus another pi over 2 will give me pi, plus another pi over 2 will give me 3 pi over 2. Now this won't make a lot of sense to you. All I'm trying to do is get you a little bit familiar with this. So if we look at our little chart, see how this is 270 degrees right here? 270, what did that convert into? It converted into 3 pi over 2. That's what I wanted to show you. What about 180 degrees? 180 degrees, what did it convert into? It converted into pi. What about 90 degrees? 90 degrees, it converted into pi over 2. So all I'm going to do is these first few right here. 45 degrees is halfway in between 0 and 90. So what would that look like in radians? What does this look like? Well, 45 degrees right here is halfway between pi over 2. If we took pi over 2 and divided it by 2, we'll get pi over 4 is what that looks like. Right here in degrees, if we just went up 30 degrees, if we went up 30 degrees right here, this is 30 degrees. What would that be? That converts to pi over 6. Pi over 6. What if we go up 60 degrees? Right here, 60 degrees. What does that convert to? Well, that's going to convert to pi over 3. So I'm not doing this systematically, really. I'm just kind of showing you. I want you to get used to seeing radians and degrees, okay? Now, on your next part of the worksheet, we're going to look at angles and how to draw them. There's a lot of XY axes. So there's 8 of them that I put on your worksheet. Before we do that, I'm going to just do a practice round, just showing you what some words mean and what some angles mean. So this is, these are the same angles. One is in degrees, one is in radians. Now, let's look at this. What if I just want to draw a couple of angles. So let's just say I have a circle here, okay, and I want to talk about angles. So, well, maybe not even circle. I just have an axis here. We know that you can call out an angle in 2 different ways. So first, let's draw an angle. Let's draw an angle called 37 degrees. If you had to draw an angle in standard position at 37 degrees, the initial side will always be the positive x-axis. Okay, so we are just kind of sketching an angle. This is not super exact, but we know if this is 0 degrees and this is 90 degrees, 37 degrees is going to fall somewhere in quadrant 1. And so just as a reminder, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. And what's significant about each of these quadrants is that in quadrant 1, the x and the y are both positive. In quadrant 2, the x is negative, the y is positive. In quadrant 3, both the x and the y coordinates are negative. And in quadrant 4, the x is positive and the y is negative. So we'll be referring to this as we go through the class. But these are the different quadrants. So right here in quadrant 1, this contains angles from 0 to 90 degrees. So if we were going to draw this angle in standard position, 37, we would say, okay, maybe it comes up to here. This would be theta. So this is how it would measure counterclockwise because it's a positive angle. What if they said, let's draw this angle? Let's draw theta equals to 125 degrees. Where would we think that one falls? Well, this is standard position. This is 0. This is 90 right here, and this is 180. It's going to fall somewhere between 90 and 180, so maybe it falls right there. So this is how we could sketch this angle right here. That would be theta. This is supposed to be a little arrow. That would be theta right there. Theta is 125. What if they say draw a negative angle? So remember, negative angles go in a clockwise position. So what if they said, let's draw this. Theta is negative 110 degrees. How would we draw that? Okay, this is how this goes. From here, clockwise to here would be negative 90. So from it's going to be between, and from here to here would be negative 180. So negative 110 is going to be between negative 90 and negative 180. So maybe it would be like, maybe here. So we could say this is the initial side and this is the terminal side for negative 110 degrees. So positive angles go counterclockwise. Negative angles go go clockwise. So that's how you would draw that. What if they ask us to do it in radians? We could also draw it in radians. So what we're about to enter into is practice drawing angles in standard position. Now, there's a word called coterminal. I mentioned it once earlier in this video, and here it is again. Coterminal angles are angles that have the same initial and terminal side. So here was the first one that I sort of mentioned was 0 degrees and 360 degrees. So if this is some axis, okay, let's draw an angle. If this is 30, let's do 0 and 360. So here's a coterminal angle. Here, let's do 90. Here's one angle. From here to here is 90 degrees. Okay, what if they say draw a coterminal angle? That is another angle that has the same initial side right here and same terminal side right there. How could we make that happen? Well, we could do it this way. We could circle 360 and then add another 90. So let's do that. This is what that would look like. You could go all the way around 360 and then go another 90. So what this would look like would be 360 plus 90, and that would be, what in the world? Let me add this. I don't know what that is. 0, 9, 10, 11, 12, 13, 14, 15. That would be 450 degrees. So 90 degrees is coterminal with, whoops, I left off the 0, with 450 degrees. Okay, let's do another angle that 90 is coterminal with. What could we do in that case? Well, we could go negative. We could say this is the initial side right here, same initial side, and this is the terminal side. What if we started here and then we went that way? Well, what would the blue angle be? Well, the blue angle would be 90 minus 360, which would give me negative 270 degrees. So also, it's also coterminal. 90 is also coterminal with negative 270 degrees. You can go negative that way. So turns out there are an infinite amount of angles that are coterminal with other angles, because you can just always keep adding 360 and cycle around and cycle around and cycle around. You can find an infinite number of coterminal angles with 90 or with any other angle. You can do this with degrees. You can also do this with radians. So let's just practice, and then we'll do the what I have on our worksheet. We're still practicing. What if we did it in radians? What if we said, let's find a coterminal angle something coterminal with, let's see, here's my circle. Let's say we've got, this is pi over 6. Let's say this is the angle pi over 6. Let's find two angles that are coterminal with pi over 6. Well, here's the initial side, right? Here's the initial side, and here's the terminal side. So this is this angle right here. So let me erase this part. I don't need this whole circle for this demo. For this illustration, we just need this, this much of our axis. Okay, from here to here is pi over 6. So let's find two coterminal angles. Let's do a positive angle. So I'll try to stick with the same colors. Green will be positive. So what did we do here? We went all the way around 360, and then we went up, and 2 pi is one cycle, and then we added pi over 6. So the green angle is 2 pi plus pi over 6. Okay, this is, let's add this. This is 2 pi over 1 plus pi over 6. Get a common denominator of 6 times 6 over 6. We get 12 pi over 6 plus pi over 6 gives us 13 pi over 6. So pi over 6 is coterminal with 13 pi over 6. If we wanted another positive angle, we could go around and add another 2 pi, add another 2 pi, add another 2 pi. You could find a bunch of coterminal angles. What if we want a negative coterminal angle? We could go the opposite direction. We could go clockwise. So we could start, here's the initial side, right? Here's the terminal side, here. We could take pi over 6 minus 2 pi. If you give that a denominator of 1 and say times 6, this is going to be pi over 6 minus 12 pi over 6 gives me negative 11 pi over 6. So pi over 6 is coterminal with negative 11 pi over 6 and 13 pi over 6, plus a bunch of other angles. We could just keep adding 2 pi, 2 pi, 2 pi, or subtracting 2 pi. Subtract another 2 pi, and you'll get more coterminal angles. So now, on your sheet, there are 8 grids. I'm going to go through this fairly quickly because I think I've explained it, and now you guys can just practice this. And so I think maybe I'll try to do this in one of our Zoom sessions coming up. So here are the 8 little grids, and the instructions for these are to sketch and label one positive angle and one negative angle coterminal with the given angle. So I haven't given you the angles yet. We're about to do that. So here we go. Here are the first 4. And then here's the second 4. Okay, those are X, Y axes. So it says sketch the angle in standard position. So the first one I want us to do is 68 degrees. And then the next one's going to be 170 degrees. And then the next one's going to be 340 degrees. And then the next one's going to be 255 degrees. So the first job is to sketch it in standard position. So the initial position is always the positive x-axis. And so 60 degrees is going to be somewhere between 0 and 90. So we're just going to sketch it up here. This will do, and we will label this 68 degrees. Okay, so let's just first go through and let's sketch each one of these. Where will 170 fall? Well, this is 0 degrees. This is 90. This is 180. So 170 will be probably close to 180. So I'm going to say this right here. This is what theta is, 170. All right, 340 degrees. If this is my initial side, this is 90, this is 180, this is 270, all the way to here is 360. 340 is going to be a little bit less than 360, so it's going to be probably here. So here is what theta is in this case. Okay, how about 255? Where will that guy fall? Well, let's see. 0, 90, 180, 270. It's going to be between 180 and 270. So maybe here, here's my initial side, and here's my terminal side. From here to here, is theta. These are angles in standard position. Now, the job is to draw it in, the next job is to draw coterminal angles, one positive, one negative. So, since I think I'm going to pause it right here so give you guys a break, and we're going to come back and we're going to do the coterminal angles because this video is getting kind of long.